Today we're going to talk about data distributions. Our learning target today is I can classify a distribution as uniform, normal, skewed left, or skewed right. And my other learning target is that I can identify measures of center and variability to the shape of the distribution. Our warm-up today, we're going to talk about classifying each of these as a measure of center or a measure of variability. We have mean, median, interquartile range, and range. So stop the video and think about what each one of those are. Is it a measure of center or is it a measure of variability? Okay, so welcome back. So when we talk about mean and median, we talk about those as measures of center. Those two things that we find, the middle number of the value of the data set and the average data of the data set, are called measures of center because we're measuring where the middle of all the data fall. In the interquartile range and the range, we're talking about measures of variability. And those are talking about how spread out the data is away from the mean and the median. So there are two different ways that we can classify or describe our data. We can use measures of center and measures of variability, but depending on what your data looks like, depends on what you're going to use to describe your data. A set of data collected to answer a statistical question has a distribution. Basically, a distribution is only how the data is spread out, how the data values occur. We have two different ways of describing data. We can describe it using the measures of center or the measures of variability, or we can do both. But we have been looking at distributions of data and finding the measures of center and the measures of variability. So when we look at those, we want to describe the distribution in three ways. We can describe it by its center value, its shape, and its spread. So these, the first two of what we've been looking at and how to figure those out, and now we're going to look at the shape. When you plot all of your data values on a histogram or a line plot, you can classify them by how they look, the shape. There's four different types of shapes. There's a normal distribution, uniform distribution, skewed left, and skewed right. And we're going to talk about each one of these. Our normal distribution is what we're going to start with. So a normal distribution is how the data was just a way of describing the shape of the data. Think of it as a bell curve. When we plot the data on this histogram, it looks like a bell. So on the left-hand side, it is slowly increasing in value. It gets to a point in the middle of the data, and then on the right-hand side, it is decreasing in value. Okay, so see how that makes a really nice bell curve? It's shaped like a bell. So think of a normal distribution as a bell curve. The middle interval on this histogram is where the greatest frequency lies. Okay, it's the tallest one, and that's where the mean and the median are. Usually they're in the very middle of the data set. This distribution, remember, is not perfect, but that means that all the data is evenly spaced, coming up to the median and then coming down to the end. So the mean and the median are approximately equal. So that when we look at a bell curve, the mean and the median both reflect the measures of center accurately. You can use the mean and the median to describe your data. You can also, if you want to, describe your data using the measure of variability. You can use the interquartile range or the range. They both reflect the variability correctly because all the data is evenly spaced. The next curve is a uniform distribution. So a uniform distribution, you can see how the data is spread out equally among all the intervals. So we're looking at histograms and dot plots because when your data is plotted in each one of these types of graphs, you can see the shape of the data. So in the histogram, you can see that this is a flat surface. Every single interval in the histogram are exactly the same. And again, the mean and median are directly in the middle of the data. There's an equal amount of data on the left and the right-hand side. So you can see over here on the dot plot, we have a pretty flat curve or distribution. We do have a couple values that are higher than the rest of them, but overall, it looks like the data is pretty evenly dispersed, exactly the same. So when we talk about a uniform distribution, I want you to think of a block, that's straight across. Just like this, a block of wood. When we have a uniform distribution, the mean and the median are accurately reflect the measures of center. And so when we talk about the measure of variability, we can also use the interquartile range and the range because everything is equal amount far away from the mean and the median. So in each one of these, the mean and the median and the IQR and the range both reflect, they all reflect accurately the way the data is spread and the middle of the data. Not so much with a skewed left distribution. Look at how in a skewed left distribution, the numbers on one side are lower than the numbers on the other side. So I think of it as it could be a monster with his tail going out to the left like this. Okay, when all the data is piled up and clumped to one side, we call it a skewed distribution. Now it depends on which side the data is skewed to. So as you look at this skewed left, our tail is pointing to the left. In a skewed left distribution, the data is clumped to the right side of the mean and the median. So it's the opposite of where the data is. If the data is all clumped over here on the right, it's skewed to the left because it's pulling the mean to the left. So it pulls all this data over to the left. There are less data values on the left side of the mean and median than there are on the right-hand side. So that's why it's called skewed left. This distribution, when everything's skewed to the left, the mean will be less than the median. Okay, down here it says the mean is less than the median because all the data is being skewed because there's probably some outliers over here that's pulling that average out away from the middle of the data values. So in a skewed left situation, or really in any skewed graph, the median is going to be a better measure of center. And the interquartile range is going to be a better measure of variability. We don't care about those outliers when we talk about the interquartile range. They're not part of our measure of variability. And the median, same way. The median tells you the middle number. And you can look at your numbers. Remember when we looked at the median, you can look at numbers that are way far away from the median as an outlier. So, as we have a skewed left, we also have a skewed right distribution. So remember that the distribution, if the data is all clumped to one side, the graph is the opposite, called the opposite, okay? So all the data you see here, it's all clumped to the left-hand side. But we're going to call this a skewed right distribution because the mean is pulling all the data to the right. Okay, the mean is being pulled to the right. So this looks like a dinosaur with his tail out here. Okay, his tail is going toward the right. So that's why we call it skewed to the right. All right. It's the data values are going to be less on the right of the mean and the median. And the mean is going to be greater than the median here when we have skewed right data. All right, so this is, again, the mean and median is not going to be a good measure of center because it's being affected by any outliers on the right-hand side of the data. The interquartile range and the median are going to be better measures of describing your data. So remember, we can describe it by the shape, so it's skewed to the right, and we can also go on to describe it using the median or the interquartile range when we have skewed data. So in the classroom, you can download this handy handout. It will give you the shape of the distributions, the name, and whether the mean and median are in the middle, or if the mean is less than the median or the mean is greater than the median. It gives you a lot of information here just at a glance. So please download this from your classroom and keep it handy for your math, in your math folder. So you have, in Classkick, you have an assignment. You have 12 problems. You're going to look at these graphs and you're going to decide whether it's skewed to the left, skewed to the right, or, you know, there are different questions, or what kind of a distribution do we call it? I want you to look in Classkick for S2W3, today's date, 4/10/23, data distributions worksheets. You can come back and look at this worksheet or this handout that's in the IXL Classroom to help you with this assignment. All right, there's 12 problems there, so you're going to have to click through to each page. There's one problem per page. So finish that up. When you're done with it, save it as a PDF onto your computer, then submit it to the Dropbox in today's IXL Classroom. I hope that helps with distributions. Go ahead and take a break, and then go ahead, you can work on your math assignment in Classkick. Have a great day.